So for this we have the integral of 3x squared multiplied by the square root of x cubed minus 2 with respect to x. So the first thing we're going to do is we're going to rearrange it, and we're going to write it in parenthetical form. So I do have a parentheses to a power. That is not going, even if we wanted to, we couldn't distribute that because it has the 1/2 power on it. So there's no way to distribute. So we're going to have to hope that sacrifice works or substitution. So what we're going to do is look at the derivative of the inside, and that is a
3x squared.
3x squared. So I have exactly that. I don't have to make up any numbers. I have exactly a 3x squared, and I'm just going to sacrifice them. Like, boom, he's gone. Where'd he go? Volcano. Right? He went to the integral God's volcano?
Yes.
And they're like, yum, yum. And now they're like, you can add 1 to this power now. So we have x cubed minus 2 to the 3/2 power multiplied by 2/3 plus c. And if you want to change that to radical form, you certainly may. I'm not sure why you would want to, but you could. Some people just like the look of radicals.
Awesome.
Yeah. The next one looks a little scarier.
Mm-hmm.
We're gonna attack it together, okay? Yeah. You do. The first thing you need to do for the next one is bring it up and write that parentheses to the -2 power. And then we'll talk about, how to handle it when you have numbers you don't need to give away. Like, what do we do with them? So we'll pull this up to the top, and I'm going to go ahead and set it in front here. So I'm going to put it here. And then I still have this -3x and the dx multiplied out to the side. Now, to integrate this, I need to sacrifice a -4x, not a -3x. And you're not allowed to just say, like, oh, let's just subtract 1 and turn the -3 into a -4. You're only allowed to multiply or divide something in. You are not allowed to add or subtract something in. Make sense? Okay, so what we're going to do is we're going to take this 3 and we're going to pull him out and say, like, we don't need you. So we're just going to shove you to the front. We're going to kick you to the curb. We're not going to worry about you right now. So because I don't need the 3, I need a 4 there. Take him out, put him in front. And just ignore him for a while. So now we still have our negative, we still have our x, we still have our dx. But we are now in the position to make up a what?
4.
A 4. So we'll multiply a new 4 in, and we will divide a 4 out, which is the same as multiplying by a 1/4, right? So I'm just going to put this over 4 out here. So the 3 is there because we pulled him out. The 4 on bottom is there because we had to multiply in a 1/4 to balance. But now we're in a position to sacrifice exactly what we need, a -4x dx. So over to the integral gods. And then you can do the power rule.
Sweet.
Add 1 to the power. Divide by the new power. Ooh, that's not pretty looking. Okay, so really that's just -3 on top, right, you guys? The negative comes out to the front. We don't want to leave it on the bottom. We have a 3 on top, and on bottom we have a 4, and this guy drops back to the bottom. Plus c. So what do you guys think?
That was ratchet.
Not too bad? I didn't think it was that bad.
It wasn't like awful.
So if you have a variable you don't know what to do with, you're in trouble. Like, you're going to have to figure out a way to distribute.
Yeah.
But if you have a number you don't know what to do with, numbers don't bother us. Just pull them to the front and don't worry about them. You just aren't allowed to bring out a variable.
Okay.
So for this one, we're going to bring this up into the numerator and rewrite it in exponential form. So we're going to have 3 minus x squared to the -1/2 power. We already have an x up there and a dx. And in order to make this work, I need to give away a -2x, the derivative of the inside here, -2x. I have the x, I have the dx, I just need a -2. I can multiply that in and make him up.
Amen.
And then I can put him out here as a -1/2 to balance him. This is what we give away. It allows us to reverse the chain rule. Add 1 to the power, divide by the new power, add some c. Add 1 to the new power, and that becomes what?
-3x.
Add 1.
Negative,
Positive 1/2?
positive.
right? Is that right, you guys?
Yeah, that's
Add 1 to the power, divide by the new power, which is the same as multiplying by
It's yours.
2 over 1. So the negative 1/2 and the 2 over 1, oh look, they end up doing what?
Negative one.
They cancel. So we really have just a negative 1, 3 minus x squared to the 1/2 plus c. Or you can change it to radical form if you so choose.
This is bomb.
I want you guys to try the next one. Now keep in mind that one way to do the next one would be to just FOIL it out. You could do that. It is just a FOIL problem. But I would like you to try it by sacrifice. For this one, we are going to need to give away a what? Negative 7 dx. I don't have a negative 7, I have a positive 5, so he's not really helping me at all. But because he's a constant coefficient, we can move him out front and just ignore him for a while. We'll just kick him out. And that will let us work with what really concerns us. So we need to make up a negative 7, so we'll multiply a negative 7 in. And normally what I would do is I would balance that with a negative 1/7, but do y'all understand that's the same as just dividing that 5 by negative 7?
Yeah.
Okay, so I'm just going to put like a negative 7 over here. That will allow us to integrate. So we have negative 5/7, 3 minus 7x to the 3rd power, all divided by 3, plus c. And then you just clean them up. So negative 5, 3 minus 7x quantity cubed over 21. And if you want, you can leave the negative 5 over 21 out in front. It really doesn't matter. And I think we're just going to stop there for today. And we'll look at all of the trig ones next time together. Because I think you might want to go ahead and start on practicing this before you have any trig thrown in. So go ahead and start kind of playing around with 1 through 37 odd. But after next class, we will have another day in class where you can just practice. This is going to take practice. So don't feel like you have to get it all done. When do I see you? Monday. So at least try to have half of it already done, and worked on.
Ooh, maybe I'll do it on the way to Homewood. Oh wait, no.